Imagine this. In a world where every child learns about space from glowing digital screens or through immersive VR headsets, there's a small school in Pune, India, where the cosmos comes alive through the soft whir of a 70-year-old mechanical projector. Here, students aren't clicking through simulations. They're gazing up at a night sky recreated with the same machine that once wowed their grandparents. And against all odds, this old dome isn't just surviving, it's sparking a revolution in how we teach science. But in an age ruled by technology, can a relic from the 1950s really compete or even outdo the dazzling digital future? That's what we're uncovering today, a journey from the birth of Asia's first school planetarium all the way to the crossroads of old wisdom and new tech. And trust me, what's happening here could flip what you think about education and opportunity on its head. Inside a historic yellow brick school in Pune's Sadashiv Path, tucked away from the shout of traffic and the glare of modern billboards, there is a dome like no other in Asia. Modest at just 9 meters across, the Kusumbai Motachan Planetarium contains not rows of computer monitors or neural networks, but the gleaming, almost steampunk silhouette of a Spitz A1 projector, designed in the United States when Sputnik was barely a dream. To really get why this is extraordinary, we need to travel back to 1954. Television was a luxury. The idea of humans traveling to space sounded fantastical. But at New English School, a group of educators, guided by the vision of the Deccan Education Society, chose to invest in wonder. Instead of just blackboards and textbooks, they installed India's first projection planetarium, catapulting their students into a new era of learning. The Spitz A1, developed by Armin Spitz with none other than Albert Einstein himself as an advisor, was built for one goal: make astronomy accessible and affordable to everyday kids. It's the only one of its kind still in regular use anywhere on the planet. It's not just a science tool, it's a bridge between heritage and hands-on learning, says Vinayak Ramdasi, the school's passionate science educator who has led the planetarium's revival since 2012. And what a revival it's been. Over 40,000 students have sat beneath its dome, watching the universe come alive, not from a textbook, but from the whirring, shifting arms of a mechanical sun and stars. The Spitz's magic is its versatility. With a bit of careful programming, it can project the exact sky seen from any location on Earth, at any time in history, or even the future. When India's first astronaut, Rakesh Sharma, visited in 2017, Ramdasi dialed in the sky above Russia precisely as it looked during Sharma's legendary launch. Sharma's delighted reaction, that moment of personal cosmic connection, translates to the hundreds of wide-eyed students who get to experience their own place in the universe every single week. But this story isn't really about nostalgia, it's about impact. Because while the world outside is racing toward fully digital planetariums, lavish LED-lit domes and VR experiences that cost tens or even hundreds of thousands of dollars, Pune's mechanical dome is delivering something the latest tech often can't: genuine, hands-on curiosity. Every Friday and Saturday night, the school campus transforms. Instead of the usual homework grind, nearly 200 students become amateur astronomers, learning to operate telescopes, track planets, and map distant nebulae. More than 1,000 planetarium shows have been held since 2010. Some even happen at dark sky sites outside the city, far from the light pollution of urban India. For many students, it's the first time they've truly seen the stars, free of smog and the distractions of daily life. And here's something remarkable. The planetarium isn't a museum piece, it's a springboard. The school's astronomy program goes far beyond the dome. Through lively night sky camps, shadow experiments to measure Earth's size, and daily classroom quizzes known as A Question on Astronomy Every Day, the students are taught not just to memorize constellations, but to question and discover. The initiative has sparked more than 20,400 discussions in just 7 years. It's inquiry-based education, in the spirit of pioneers like astrophysicist Jayant Narlikar, who once said, "Asking questions is the true foundation of science." Arnav, a passionate ninth grader, says, "Our school is not just preserving India's history, we're creating it. Within just a year, I've developed the skills to study planets and stars. The first time I saw Saturn through a telescope, I knew I wanted to become an astronomer." All this powered not by megabucks or state-of-the-art VR headsets, but by a dedicated group of teachers and a quietly ticking machine built in the 1950s. But can such wonder last? Today the pressure is on, not only for Pune's planetarium but for astronomy education across India and the world. While nostalgia makes for a great story, students and parents are constantly tempted by the glitz and apparent convenience of digital tech. Why sit under a mechanical dome when you can explore the galaxy using an app or zoom in on Jupiter with a VR headset in your living room? Dr. Aniket Sool, National Astronomy Education Coordinator, puts it simply: engaging students with hands-on activities and real-world applications is crucial for fostering a deeper understanding of astronomical concepts. But even he admits that digital transformation could be both a blessing and a curse. Let's trace where we are today. Since 1954, Indian astronomy education has exploded in variety. Organizations like IUCAA, the Inter-University Center for Astronomy and Astrophysics, and Space India have introduced new curriculums, developed outreach programs, and reached remote rural communities with initiatives like Astronomy on a Camel Cart and Sky on a Bike. The idea is clear: democratize astronomy so that even the most underserved communities, girls in rural villages for instance, can look up and feel that sense of empowerment and discovery. Space. India alone delivers STEM and astronomy programs to over 500,000 students every single year. The Astronomical Society of India bridges research, education, and public excitement with national symposia and workshops. And with the recent establishment of the International Astronomical Union's India Center, efforts are underway to standardize and upgrade astronomy teaching for the entire country. Sounds like a good news story, right? But here's where things get tricky. The very tools that make astronomy accessible, apps, VR, digital domes, could also create a new kind of divide. Most Indian schools, especially in smaller towns and villages, can't hope to afford the latest digital planetariums or VR headsets. Even if they could, the lack of trained educators to run these technologies is a major hurdle. Dr. Surhood Moore, National Astronomy Education Coordinator, cautions: effective astronomy education requires continuous assessment and development of teaching methods to meet evolving student needs. There's also the risk of missing the very thing that makes science stick: the sense of wonder you get from real, hands-on, messy experimentation. Sure, apps can show you the rings of Saturn, but can they give you that electric, unforgettable moment of seeing it with your own eyes, through a telescope you've learned to operate, under a real night sky? Policymakers now face a dilemma. Should India, and countries like it, plunge full speed into digital transformation, pouring precious resources into the latest equipment? Can the deep roots established by heritage programs like Pune's Planetarium coexist with, or perhaps even strengthen, the new digital wave? Or will the glint of technology erase the living legacy of places where science is learned not just from screens, but from experience? Meanwhile, educators are frantically adapting. Some champion blended learning, combining physical planetarium shows with digital simulations and online coursework. Others warn that if we lose the tactile, community-based wonder of real-world stargazing, we risk turning science education into just another screen-based chore. And the stakes aren't just national. Astronomy is a gateway to STEM careers and economic opportunity for millions of young Indians, especially those from marginalized backgrounds. The right approach could empower an entire generation. The wrong one could widen the gap between those with access to high-tech learning and those left staring at the sky, unsupported and uninspired. So here's the big question. In a country surging forward on the digital wave, can the humble, hand-cranked domes of the past survive and maybe even outshine the brightest virtual star fields? Or will the push for technology leave historic, hands-on education lost in its shadow? As the nation's education policymakers, teachers, and students stand at this crossroads, the next moves they make could reshape the very future of science learning in India. But with so many challenges and opportunities, what path should they choose? And could the answer to unlocking a scientifically curious, empowered generation lie in something as simple as a clear night, a curious mind, and the soft whir of a vintage projector? That's the billion-dollar dilemma we'll unravel next. Now let's peer into what the future may hold for both the storied dome in Pune and India's grand experiment in astronomy education. The landscape is shifting quickly, faster, some say, than the stars themselves seem to move, and every choice we make now has lasting ripples. Imagine walking into a classroom in 2030. There, a student dons a virtual reality headset, and in an instant, she's orbiting Saturn's rings, guiding a simulated spacecraft through the asteroid belt, or witnessing the birth of a star in a far-off galaxy. Such technology is not science fiction anymore. It's being piloted in elite urban schools across India today. Digital domes, immersive software, and AI-driven sky simulators are proliferating, promising a form of space travel limited only by imagination, not geography or weather. This digital revolution is exhilarating but comes with a double edge. As more schools invest in high-tech setups, there's a real risk that the magic of hands-on discovery, of holding a telescope, of listening to the whir of an old projector, of arguing under a real sky about whether that fuzzy patch is Andromeda or just a passing cloud, may fade from memory for an entire generation. The stakes are high. Will we raise students who see science as a button to press, or as a journey to be lived with all senses involved? Dr. Aniket Sool, one of India's leading astronomy education experts, issues a gentle warning. Engaging students with hands-on activities and real-world applications is crucial for fostering a deeper understanding of astronomical concepts. Yet, the sketch of the future isn't black and white. There are extraordinary opportunities if we can thread the needle between the past and the future. What if digital planetariums could be used not to replace, but to amplify the experiences found in Pune's historic dome? What if virtual reality journeys were paired with real telescopic observations, where the simulation sets the stage and the sky itself delivers the punchline? Many educators and scientists now advocate for a hybrid model, a blend of tactile, physical experiences with digital enhancements. Such a model would acknowledge that, while VR can take us to the surface of Mars, nothing quite matches the thrill of identifying Jupiter's moons through a trembling lens, or aligning a classic Spitz A1 projector and watching the constellations shift, just as Albert Einstein envisioned they could for curious young minds. But this future is not guaranteed. Several risks lie ahead. First, access and equity. The cost of digital domes and sophisticated VR systems is prohibitive for thousands of rural schools and underfunded urban classrooms. If technology alone becomes the new gold standard, a generation of children could be left behind, their wonders stifled by a lack of resources. The Kusumbai Motichand Planetarium, with its open-door policy and modest means, stands as a crucial counterpoint, an example of how heritage and ingenuity can keep science accessible to all. Second, training. Digital education tools are only as powerful as the teachers using them. The best VR system in the world can't ignite curiosity if the educator merely presses play. Dr. Surhood, more of the International Astronomical Union's Education Center in India, stresses, effective astronomy education requires continuous assessment and development of teaching methods to meet evolving student needs. For the magic to last, teachers must be equipped not just with gadgets, but with the spirit of inquiry and the skills to spark questions. Third, the risk of a passive learning culture. There is a subtle, haunting danger that digital marvels, while dazzling, may encourage students to become mere consumers of awe rather than creators of it. The tactile rituals of pointing, measuring, aligning, and discovering together, these are rituals that build resilience, teamwork, and joy in the messy business of learning science. But let's not overlook the extraordinary possibilities that the digital age brings. Democratized access through mobile astronomy units like the Sky on a Bike initiative, which brings telescopes and sky shows to underserved communities, or the Astronomy on Camel Cart project rolling across rural Rajasthan. When technology and tradition unite, whole new frontiers open up. Recent nationwide surveys reveal a promising trend. Even as digital tools gain ground, there's a growing grassroots movement to preserve and modernize traditional planetariums. Schools like New English School are not clinging to the past. They're actively seeking partnerships, upgrading teaching materials, and sending their educators for training with institutions like IUCAA and Space India. The vision? To become centers where curiosity is not a museum artifact but a living force. So, what does all this mean for you, the viewer, the parent, the student, the teacher, or the simply curious mind? First, recognize that the heart of science learning is, and always will be, curiosity and inquiry. Whether you're watching the stars from a rooftop, building a paper model of the solar system, or donning a VR headset, the moment a question sparks in your mind is the moment real learning begins. Dr. Jayant Narlikar put it best. Asking questions is the true foundation of science. Astronomy education should encourage inquiry and critical thinking. Second, seek out or advocate for educational experiences that combine both digital and hands-on elements. If your school has access to new technology, ask how you can pair it with real-world experiments. If not, remember that the night sky is free, and the skills you build under it are priceless. Organize or join observation nights, science clubs, or local astronomy workshops. The Astronomy Society of India and many outreach groups regularly host events for students and adults alike. Get involved. Third, support efforts to make science education accessible. If you're a teacher or parent, look into outreach programs, citizen science initiatives, and even mobile planetarium experiences. India's most creative programs, like the empowerment of disadvantaged rural girl children with astronomy, show that basic, inquiry-driven learning can change lives, build confidence, and sow the seeds of scientific careers, regardless of a child's background. Fourth, don't underestimate the power of community in science. The Friday and Saturday night observation sessions at New English School are more than just lessons. They're vibrant, noisy, joyous gatherings where young astronomers learn from each other, debate new discoveries, and sometimes even challenge their teachers. Find or build your circle. Learning together multiplies the magic. And finally, cherish and defend spaces like Pune's School Planetarium. These places are rare. They are bridges across time, carrying forward not just content, but the living culture of scientific wonder. If you ever visit or have the chance to support such initiatives, remember, you're helping preserve a living laboratory where tomorrow's scientists, thinkers, and dreamers are born. As we reach the finale of our journey, let's return to the big question. Can traditional, experience-based science education coexist and even thrive alongside high-tech digital models, or is it destined to be eclipsed? The answer, a resounding yes, is written in the sky above Pune and in the eager faces of its students. Tradition and technology are not rivals, but allies. Each fills the gaps left by the other. The mechanical whir of the Spitz A1 projector reminds us that awe can be built from screws, gears, and the simple genius of an engineer. The silent immersion of a VR headset reminds us that imagination knows no boundaries. When fused together, when digital tools enhance, not replace, the hands-on excitement, we prepare a generation for a future in which the next great discovery could come from anywhere. In the words of Vinayak Ramdasi, our school is not just preserving India's history, we're creating it. Every time a new student sits under that dome or points a telescope at Saturn's rings, a spark is lit. And sparks, as we know, can become stars. Here's a secret fact you might not know. The Spitz A1 projector at New English School isn't just India's first school planetarium. It may be the last of its kind in the world, still running regular shows. A living link to the vision of Albert Einstein himself, whose advice helped shape its design. So, what can you do? Look up. Champion curiosity. Whether you pursue astronomy in a digital dome, a classic planetarium, or under an open sky, remember, the universe belongs to all of us. Your questions matter. Your wonder matters. Protect it. Share it. And if this story inspired you, please like, subscribe, and share your thoughts or your own star stories in the comments. Maybe you're the next trailblazer who will keep the flame of curiosity burning bright for future generations. Thank you for exploring with us beneath